Hi guys, hope you're doing well. So today we are going to finish up section 5-5. So as you know, we left off on example 4 in our notes. So make sure you're on example 4 in your notes. Today we're going to be talking about composition of functions, and this is going to be a little bit new, and a lot of this is used in pre-calc, so it's a really important topic. So here we see f of x is x squared and g of x is x plus 1. And it says investigate what happens when you apply the rule for g and then the rule for f to a number or a variable. So find the value of f of g of 3. Now when I'm doing these problems, f of g of 3, that's not really something that I'm familiar with. But have you seen something like g of 3 before? Of course. So g of 3, just looking at the inside here, g of 3 means in the function g, which is right here, right? In the function g, I'm going to substitute 3 in for x. So everywhere I see an x, I'm going to substitute a 3. So g of 3 is 4. Now this is something I'm familiar with. Well, if g of 3 is 4, do you agree I could take out g of 3 and replace it with a 4 since g of 3 is 4? So really I'm just finding f of 4. Well, what does that mean? It means take 4 into the function f, substitute it in for x. So 4 squared, which is 16. Therefore, I could now say that f of g of 3 is 16. So I work inside out. It's saying find g of 3. Then take what g of 3 is and substitute that into f. Okay, so we're working in to out. How I read this out loud? This reads as f of g of 3. Let's look at our second example. Now it's saying find the rule for f of g of x. Now before we begin with this problem, I want to just talk about two different types of notations. So f of g of x, so every time I have these parentheses here, I say the word of, is the same as f of g. So some people write it this way, some people write it this way. It looks like the word fog. Not to be confused with this, right? This means multiplication. This means composition. So, we're going to talk about what that means in a second. But anytime you see the open circle, it is not multiplication. It is a composition, read as the word of, okay? So if you do see it like this and you're more comfortable seeing it this way, right when you see f of g, you could then write it in this notation instead. Either one. Now what does this mean? This is saying take the function f. Well, here's the function f. Instead of x, I want you to replace it with g of x. This is g of x. So, in the function f, this is how I prefer to write it. The function f, the one on the outside, is x squared, so something squared. I like to leave blank parentheses. Why? Because I want to, instead of x, I want to replace it with something. What am I looking to replace it with? G of x. What's g of x? Well, g of x is x plus 1. So I'm going to put in x plus 1. So does everyone see what I did there? I took this function f, x squared, and instead of x, I take out the x. I put in g of x, x plus 1. All right, so Now I need to simplify. So what does x plus 1 squared mean? It means x plus 1 multiplied by itself. So then I FOIL, I get x squared plus x plus 1, giving me x squared plus 2x plus 1. And this represents f of g of x. Now, I'm going to add on a question because I know it was mentioned in the beginning of this section. What is the domain here? This is a quadratic, right? Is there anything I can't square? Is there anything I can't multiply by 2? Think about the graph. The graph is just a parabola, right? So what is my domain? What are the possible x values? All real numbers. So in this case, notice it keeps going left and right. So in this case, negative infinity to infinity, right? I don't have a variable in the denominator, anything like that, so there are no restrictions here. So again, I'm taking out the x in one function and replacing it with another function. So in the previous example, we replaced the variable with a number. Now we're replacing the variable with a function. All right, pause this video and go ahead and try example 4. Try it in your student companion on page 133. So notice here, it's saying f of g of 2. Anytime there's a number involved, I'm going to deal with the inside first. G of 2, it's something I'm familiar with. That's just 3 times 2, right? Plug into 4x in the function g. That gives me 6. I can now take out g of 2 and put in a 6 instead. So now f of 6, that's plugging in 6 for x in the function f. That's 12 minus 1, so I get 11. So f of g of 2 is 11. Just keep in mind, this is the same as plugging g in for x into f and then taking out the x and plugging in a 2. Same thing. So here, I want to take the function f, and instead of x, I'm going to put in g of x. The one on the inside is the one that I am putting into the one on the outside, right? So f, I always like to write it like this. Here's my function f. This is f, right? 2 times something minus 1. I'm taking out the x. There's no longer an x. What am I putting instead? G of x. Well, g of x is 3x. So I'm taking out the x and I'm replacing it with g of x. 2 times 3x is 6x, and then I have the minus 1. Notice this is a linear function, right? It's just a line. So if you think about it, looking left and right, the domain again is all real numbers, or negative infinity to infinity. All right, let's look at our next example. So this here is just talking about that notation that I spoke about before. So it could be written as f of g of x or f of g of x. It's going to sound the same, but with parentheses. Okay, so these are the two different notations. They mean the exact same thing. Do not confuse open circle composition with a closed circle multiplication. So now notice here it's written on our other notation. It looks like the word fog, right? If you don't like that, no problem. Rewrite it. F of g of x. This is equivalent to this, right? So f is the one on the outside, g is the one on the inside. So I'm taking that function on the outside, f. I'm taking out the x, so no longer put an x there. Instead of x, what am I putting inside of f? I'm putting g inside of f. Well, here's g, 2x minus 5. Now I just need to clean this up. 2x minus 5 plus 7 is 2x plus 2. Now, are there restrictions when we're talking about square root functions? Absolutely. Right, what can't we take the square root of? We can't take the square root of negative numbers. We can only take the square root of numbers 0 or greater. So 2x plus 2, if I'm talking about domain here, right? Possible x values. 2x plus 2 has to be greater than or equal to 0. Again, why? Because I can't take the square root of a negative. So if I solve this, 2x has to be greater than or equal to negative 2, and x has to be greater than or equal to negative 1. This represents my domain. How do I say any number greater than or equal to negative 1? From negative 1 to infinity. It's equal to negative 1 because I can take the square root of 0. So this is our domain. Okay. Now, if you have trouble with this, you could always graph this function. If I were to graph it, I would see something that looks like this. And I could see my domain is from negative 1 to infinity, looking left to right. All right. All right. Another one. What is the rule for the composition f of g of x again? So again, f is on the outside, right? So f of g of x. This time, like before, f is on the outside. So I'm taking the function f. Here is f. Everywhere you see an x, you're not putting it there. You're taking it out. So here's the function f. I took out the x. Instead of x, I'm replacing it with g of x. There's g of x, right? I'm putting in g of x everywhere I see an x. So now, how do I simplify this? On the side here, I'm going to write it out twice and FOIL. So 4 times 4 is 16. 4 times negative x, negative 4x. 4 times negative x again. And negative x times negative x, positive x squared. Clean this up. I'm going to put it in standard form. We have x squared minus 8x plus 16. Now, I'm going to put that back in here. X squared minus 8x plus 16 plus 4 minus x plus 2. I'm going to combine my like terms. Negative 8x minus x is negative 9x. 16 plus 4 is 20. 20 plus 2 is 22. So this is f of g of x. Again, it's a quadratic, so if I were to mention the domain, even though it's not asking for it, it would be all real numbers because it's just a parabola, right? There's no restriction on my x values. All right. Go ahead and pause this video and do the try-its. All right. So, notice here it's asking us to find both f of g of x and g of f of x. So I'm going to do both for each problem. So we have f of g of x. F of g of x is saying take f, something cubed, take out the x, and put in g of x. I would have to then write this out 3 times x plus 1 times x plus 1 times x plus 1 and multiply it out. If I did that, I should get my simplified answer, x cubed plus 3x squared plus 3x plus 1, after you do all the multiplying out. For g of f of x, this time I'm taking the function g, something plus 1. Instead of x, I'm plugging in x cubed. Well, that can't really be simplified, so therefore I just get x cubed plus 1. For part B, f of g of x, I'm going to take f, which is something squared plus 1. And instead of x, I'm going to put in g, which is x minus 5. On the side, I'm going to multiply out x minus 5 times x minus 5, giving me this. So I get x squared minus 10x plus 25 plus 1. Combine my like terms, and there we go. Finally, g of f of x. I'm going to take out the x, something minus 5, and I'm going to put in f, which was x squared plus 1. X squared plus 1 minus 5 is x squared minus 4. And that's it. So again, you're taking that function on the outside, you're writing it down without the x, and everywhere you see an x, you're plugging in another function. All right. Now this is not going to be in your notes, but let's just try an additional example. If you want to fast forward through this because you think you got this, that's fine. But I'm just going to do one additional example to make sure we have this down. So write this down. Pause this video, write this down. Here it's saying let f of x equal 3x squared plus 5 and g of x equals 7x plus 2. So f of g, again, I'm taking f. Here is f. 3 times something squared plus 5. I'm taking out the x and I'm plugging in g of x, 7x plus 2. I then am going to simplify this on the side. I'll do 7x plus 2 times 7x plus 2. And I'm going to FOIL 49x squared plus 14x plus 14x plus 4. So that gives me 49x squared plus 28x plus 4. Now, of course, I have to distribute this 3. So 49 times 3 is 147. 28 times 3 is 84. And 4 times 3 is 12. Then I have the plus 5 at the end. So I get 147x squared plus 84x plus 17. Then, if I find g of f of x, I'm now taking the function g, 7 times something plus 2. I'm taking out the x, and I'm plugging in f of x. This is what I'm putting into the function, 3x squared plus 5. I distribute that 7, and I add the 2. So I get 21x squared plus 37. And there we go. Hopefully doing an additional example helped a little bit because these could be a little tricky. Alrighty. Let's go to our last example here, example 6. Alright, so clothes you wear post discounts on social media. The store allows customers to use multiple discounts. They simply need to tell the cashier in which order they would like the discounts to be applied. So here we see $5 off your next purchase and 10% off your next purchase. Now I know you might think this is a silly question, but depending on how you use your coupons, you could get more of a discount. Have you ever heard of extreme couponing? So it's really important that you know how to calculate these discounts so that you don't spend more money than you have to, because that would just be unreasonable. So it's saying which order should we ask for the discounts. So let's make a function f of x and g of x, one for each discount. So let's let f of x represent the 5 the $5 off. If I bought a shirt for X dollars, what would be $5 off X minus 5, right? If my shirt was $20, I'm paying 15. If a radio was $100, I'm paying 95, right? X minus 5 represents $5 off. Then let's let G of X be the 10% off. Okay, guys. There's many ways you could write this. Actually, really only a couple. But easiest way to think about it is this way. If I'm taking 10% off, right? They're taking 10% off the value. How much are you paying? You're paying 90% of it, right? So what's 90% of whatever you're buying? 0.9x, right? If, again, let's make it easy. If my shirt is $10, I'm only paying $9 because I'm paying 90% of it. I'm taking $1 off because $1 represents 10% of my shirt. So if I was, for example, if I said, okay, 25% off, then I'm paying 75%. So I'd be 0.75x and so on. So here we have f of x and g of x representing two different types of discounts. Now the question is, which is going to save me more money? So I have f of g of x or g of f of x. In other words, do I want to take the $5 off and then the 10%, or do I want to take the 10% off and then the $5? So if I was doing f of g of x, that would mean I'm taking something minus 5 and plugging in the 0.9x. What does this represent? This represents 10% off, then $5 off, right? I'm taking the 10% off and then I'm going to take the 5, right? I work inside to out. Or do I want to take the $5 off, then the 10% off? So here I'm taking the function g and I'm plugging in x minus 5. So this would give me 0.9x minus 4.5. Okay. Whereas in this is 0.9x minus 5. Which is cheaper? Come on, guys, don't fail me. Which is cheaper? Do I want to take 90% of something and then take $5 off? Or 90% of something and take $4.50 off? I would much rather keep my 50 cents. I don't know about you. So therefore, I would much rather take the 10% off and then the $5 off. In this case, okay? So to do this problem, I want to create a function for my $5 off, a function for my discount, and see, well, which one do I want? Okay, which one do I want to apply first? Even though in this case, it might only save me 50 cents, money adds up in the end, right? All right. Let's try one more of these. Again, this is going to be an additional example, so it's not in your notes. You don't, but I think it's important for us to go over it because some people get confused with bonuses and tax and things like that. So looking at this additional example, a member currently has 75,000 award points. In what order should the member take the bonuses? So they could add 10,000 award points and add 5% of your award points. So which one do they want to do first? So again, let's let f of x be adding 10,000 award points. That would mean currently at 75,000. Okay, so this function generally would be the number of award points plus 10,000. G of X would be adding 5% to your award points. So what does that mean? It means I currently have X plus 5%, right? This represents 5%, right? 0.05 is 5%. So I have this many award points, but then I want to add 5%. So that would be 1.05x, right? If I added 1 plus 1.05. So anytime you're adding something like sales tax or percentage of something, you add that to what you originally have, which is 100% of what you have, right? So 1.05x. So the question here is, should I take 5% of my award points and then add my 10,000, or add the 10,000 and then take 5%? Again, I'm finding f of g of x, but really I know what x is. I have 75,000. So really I'm going to find f of g of 75,000. Or do I want g of f of 75,000? So, which order do I want to do this in? So g of 75,000, if I do that first, that is going to add that 5% first, right? So let's figure out what 1.05 times 75,000 is. That is 78,750. And then I want to find f of that. So that means I want to take this number and add 10,000. That will then give me 88,750. So this was adding the 5% and then adding the 10,000. It left me with this many award points. Here, I want to add the 10,000 first. So if I add 10,000 to this, I'll get 85,000, right? And then I want to plug that into G, giving me 1.05 times 85,000. So 85,000 times 1.05, that is 89,250. So which way do I want to go with? I definitely want to add the 10,000 points, then take the 5%, then add 5%. So always start by defining your functions. What is my one discount or my one award, and what is my other? And then try out both options. All right, guys. Go ahead and do the last try it problem. Example 6, try it, and unpause this video when you are ready. Alright, so notice here, it says that you get a 20% discount on purchases. All sales are subject to a 6% sales tax. Write a function that models this to discount the sales tax and identify the rule. So guys, I don't know if you know this, but almost anything you buy that's not food and clothes in New Jersey, there's sales tax. If I go buy headphones, if I go buy sneakers, anything, I will get sales tax added to that. So therefore, actually I don't think sneakers have sales tax in New Jersey, but in other states they do. So sales tax is something being added to whatever you're purchasing. So first of all, f of x, let's let f of x be our discount. So again, if I'm getting 20% off, I'm paying 80%. So this is my function. I'm paying 80% because I'm getting 20% off. If I'm adding 6% sales tax, that means I have 1.06x because I have the price of my product plus 6% of my product, right? So if my product is $10, I'm paying for my product plus 6% of $10, right? So 1.06x. So it says, identify the rule for the composition that calculates the final price you would pay at GameStop. Well, what's going to happen first? My discount or my sales tax? Of course, my discount. So f of x has to go on the inside because that's what happens first. G goes on the outside because after I find out the price of what I'm paying, I then add my sales tax. So I take G, which is on the outside, and instead of x, I'm plugging in f of x. I then multiply 1.06 times 8. Sorry, 0.8. And I get 0.848x. So this represents the amount I'm paying. So if I'm buying $20 worth of stuff, I plug in 20. If I'm buying $300 worth of product, I'm plugging in 300, and so on, to represent my 20% off, followed by my sales tax. All right, guys. I hope you're all doing well. Please make sure you check in if you need any help or have any questions at all. I hope you have a wonderful day.